crows cover themselves with ants. Do you know why?
To get rid of tiny parasites.
It gives them a sensational feeling.
Imagine a fish tucking itself into a gooey snot blanket before bedtime. A fungus that hijacks ants like mindless puppets. Or a crocodile inviting a tiny bird into its massive jaws for a free dental cleaning. Imagine penguins swiping pebbles to woo a mate, snow monkeys soaking in hot springs like retirees in a luxury spa, and mice battling in high-pitched ultrasonic rap duels. From octopuses hurling seashells to fireflies flashing in perfect unison, the animal kingdom is more bizarre and fascinating than your wildest sci-fi movie. Stick around, what you're about to see will surprise you till the very end. Why do crows let ants bite them? Crows aren't just clever, they're into some truly unusual spa treatments. They sprawl over anthills, letting ants crawl all over and bite them. This behavior, called anting, looks uncomfortable, but it serves two big purposes. First, the ants release formic acid, a natural pesticide that wipes out pesky parasites like mites. Second, that acid may give crows a pleasant buzz. Scientists think it could tingle in a way birds enjoy. Just like people savor spicy food. When ants aren't available, crows get creative, using citrus peels, mothballs, or even cigarette butts. More than 200 bird species practice anting, but crows often prefer the passive version, lying still while ants crawl over them. Records from the 1830s describe similar behavior in turkeys, suggesting this has been passed down for generations. Research confirms the acid interferes with parasites' nervous systems, making them easy to remove during grooming. So, if you see a crow rolling on the ground, don't worry, it's just enjoying a bug bath. Can fungi really make zombie ants? Think zombie stories are pure fiction? Meet the parasitic fungus Ophiocordyceps. It infects carpenter ants in tropical forests, discovered back in 1859 by Alfred Russel Wallace. Once infected, the ant abandons its colony, climbs about 10 inches up a plant, and locks its jaws onto a leaf vein, exactly where humidity is perfect for fungal growth. The fungus slowly devours the ant's insides, and days later, a stalk bursts from its head, showering spores to infect more ants. Researchers like David Hughes discovered the fungus releases chemicals that weaken the ant's jaw muscles, keeping it locked in place. The creepy part? It controls the ant's body without even touching its brain, like a master puppeteer. Infected ants often stagger in zigzag patterns, possibly to avoid sunlight. Thankfully, humans are safe, for now, but this real-life mind control inspired the creators of The Last of Us. Do mice rap battle? In the cloud forests of Central America, male Alston's singing mice, Scotinomys teguina, perform astonishingly fast and complex duets that humans can't hear, lasting up to 20 seconds and packed with nearly 100 notes. Their rapid-fire vocal exchanges rival the speed of human conversation turn-taking, with replies coming in less time than a blink. What makes this behavior neurologically fascinating is the division of labor in their brains. One brain system handles the actual content of the song, the trills and chirps unique to each mouse, while another region, the orofacial motor cortex, OMC, times these duets with split-second precision. Cool that OMC, and the mice slow down or even lose their ability to coordinate their singing. Researchers even simulated duets using playback, revealing that OMC neurons flexibly adjust the pace of songs, speeding up or slowing down depending on the interaction. This points to a kind of temporal scaling ability in the brain that adapts rhythm on the fly. Why does this matter? These musical rodents help scientists understand the brain circuits involved in real-time vocal communication, offering clues for how humans process conversations and a potential key to tackling speech disorders like those seen in autism or following a stroke. Why let birds in a croc's mouth? Imagine a crocodile, mouth wide open on the sun-baked riverbank, as a tiny bird waddles in to pick at the debris stuck between its teeth. This vivid image was first penned by the ancient Greek historian Herodotus, who recorded that a bird called the trochilus entered a Nile crocodile's mouth to feast on leeches. Later, Aristotle, Pliny, and Aelian echoed the tale, portraying the bird as a kind of natural dentist, cleaning out parasites and food scraps. Centuries of storytelling have linked this trochilus to modern species like the Egyptian plover or spur-winged lapwing, though no clear consensus exists, and Herodotus may not even have differentiated between similar wading birds. Despite the charm of the legend, scientific skepticism is widespread. While the story persists in folklore, there's no confirmed photographic or video evidence of any bird consistently entering a crocodile's mouth, and certainly none showing a mutualistic dental cleanup. In fact, What do exist are clever CGI clips, some from ads, used to illustrate the myth rather than document real behavior. Some naturalists still note that plovers are often seen foraging near basking crocodiles and are sometimes tolerated, regardless of whether any actual teeth cleaning takes place. A key review of the literature emphasizes that despite the enduring imagery, there's no verified proof of this relationship, and the myth may simply illustrate evolution's way of weaving moral tales about cooperation. In short, the story of the fearless little bird tiptoeing into a crocodile's mouth lives on, more as a fable than a documented behavior. Yet it beautifully captures the idea that nature sometimes thrives on surprising partnerships, even if they only exist in stories. Why do snow monkeys bathe in hot springs? High in Japan's snowy mountains, Japanese macaques, or snow monkeys, spend the icy winter lounging in natural hot springs. Their red faces steam above the water as they relax for hours, looking almost human. But this isn't just about comfort. Soaking reduces stress hormones and helps them survive freezing conditions. The tradition started in the 1960s, when a troop of monkeys watched humans enjoying a hotel's outdoor bath and decided to try it themselves. Now, the behavior is passed down through generations. Alpha females get the prime spots, while lower-ranking monkeys are often shoved aside. Grooming sessions in the warm water strengthen social bonds, and regular bathers tend to have fluffier, whiter coats, perfect for insulation against the cold. Why do parrotfish sleep in a snot bag? Parrotfish have a strange but clever bedtime ritual. They seal themselves inside a thick, slimy cocoon of mucus before they sleep. This gooey sleeping bag acts as a shield, masking their scent from night hunters like moray eels and sharks. It also traps tiny particles from the water, helping the cocoon blend seamlessly into the surrounding coral. Scientists believe the fish secrete this mucus from special glands near their gills. Marine biologists have watched predators glide right past these cocoons, fooled into thinking they're just part of the reef. If an intruder bumps into the cocoon, the parrotfish quickly wakes and darts away. These fish play a vital role in keeping coral reefs healthy by grazing on algae that can suffocate corals. With their strong, beak-like teeth, they also grind bits of coral into fine sand. One parrotfish can create nearly 2 pounds of sand each year, according to researchers at the University of Queensland. Not every parrotfish uses a mucus shield. Species living in open water rely more on speed to evade danger, but reef dwellers are loyal to their slimy nightwear. Divers exploring the Great Barrier Reef often find these see-through cocoons draped over corals. A 2018 study even revealed that the mucus is packed with antimicrobial agents, giving the fish extra protection against infections while they rest. Why do octopuses throw shells at each other? In the swirling shallows of Jervis Bay, Australia, scientists have uncovered one of the ocean's most surprising spectacles. Wild octopus tetrachus, known as the gloomy octopus, have been filmed staging some of the most unusual social encounters ever documented in marine life. Over a full day of underwater footage, researchers recorded 102 instances of debris launching, and what they discovered will make your jaw drop. These clever cephalopods don't throw with arms the way we do. They gather bits of shell, algae, or mud in the webbing between their arms, then redirect their siphon, a powerful jet-like tube near their head, underneath their body, and blast out a burst of water. The result? A projectile that can travel several body lengths, like being blasted by an invisible water cannon. Both males and females can perform these jet-propelled launches, but the numbers tell a clear story. Females are behind most of the action, accounting for a whopping 2/3 of all throws. More than half of these throws, around 53%, happen during direct interactions with other octopuses. These moments included everything from mating attempts to arm wrestle dances, and even outright territorial face-offs. Of those encounters, about 17% ended in a direct hit on another octopus, and these weren't just clumsy collisions. The most successful hits happened when the throw was delivered with high intensity, when the octopus displayed a uniform dark coloration, a telltale sign of aggression, and when silt, rather than shells, was used as the projectile. One sequence stood out. A single female delivered 17 throws in the span of 1 hour. 9 of those were clean hits, most of them targeting a nearby female she might have been sparring with, and one aimed at an insistent male. Her hit rate? Nearly 53%. In tight octopus neighborhoods like Octopus and Octlantis, where shelters and shells are highly prized, this behavior makes sense. It is a form of nonviolent conflict resolution, a way of managing personal space, and an underwater ceasefire with style. Sophistication meets spectacle in the gloomy octopus's world. Every piece of debris flung tells its own story, a declaration of territory, a rejection of unwanted advances, or just a quarrel over prime oceanfront property. And it all plays out right there, on the ocean floor, in one of nature's most unexpected dramas. How to leafcutter ants, farm fungus underground. Imagine an army of ants running a farm beneath your feet, and they've been at it for over 50 million years. Leafcutter ants are the ultimate underground farmers, cultivating fungus that can't survive without them. Using bacteria on their own bodies, they produce natural antibiotics to protect their crops from disease. In each colony, giant workers slice leaves into pieces. Medium-sized ants haul them home. Tiny gardeners chew them into a pulp to feed the fungus. Deep below, the queen, laying up to 30,000 eggs a day, rules over soldiers with jaws sharp enough to slice through your skin. In one night, a colony can strip a tree bare and move more than 4,000 pounds of soil a year, building tunnels. Their work feeds entire rainforests, improving soil fertility by a quarter. Scientists have even watched them quarantine diseased fungus like human farmers isolating a sick crop. Their efficiency is so impressive that NASA has studied their system for possible farming on space missions. Why do deer rub their antlers against tree barks? When a buck's antlers are growing, they're covered in a soft, blood-rich skin called velvet. As the antlers harden, that velvet dies and itches like crazy. The solution? Bucks thrash their antlers against tree trunks and bushes, scraping it off in ragged strips. That leftover velvet becomes a feast for squirrels and birds. Antlers themselves grow faster than any other bone on Earth, up to almost an inch a day. And the velvet feeds this growth with nutrients and oxygen. Once the antlers are hard, rubbing isn't just about comfort anymore. It's also a way of marking territory, thanks to scent glands on the deer's forehead. Deep grooves in the bark mean a bigger buck, and hunters use these signs to track trophies. So next time you see shredded bark, it's not vandalism. It's nature's way of posting a keep out sign. Why do fireflies flash in perfect unison? In the mangrove-lined rivers of Southeast Asia and the forest valleys of the Great Smoky Mountains, an enchanting spectacle unfolds every summer. Along silky branches, thousands of pteroptics fireflies synchronize their flashes, every blink linked like a living tapestry of light. Meanwhile, higher in elevation, male Photinus carolinus cluster in hardwood forests, lighting up the night in waves that ripple across the hillside. It unfolds like this. One firefly's flash becomes a signal, and in a heartbeat, neighboring fireflies respond, falling into rhythm in what researchers now call phase synchronization. It is not pre-programmed. Each insect watches a neighbor and adjusts, creating crowd-tuned harmony that is intelligent and emergent. At a test site in Tennessee's Elkmont, scientists set up panoramic cameras among swarms in June, capturing how individual fireflies behave when alone versus in a symphony of light. Solo insects flash erratically, but as soon as a crowd forms, they coalesce into near-perfect synchronicity. Photinus carolinus males typically flash in a quick set of 4 to 8 pulses over a few seconds, followed by an 8 to 12-second hush. Only during that lull do females reply with gentle glimmers guiding the ritual. These displays are not just mesmerizing, they are fleeting. Each firefly courtship lasts only a few hours over a span of 2 weeks, easily interrupted by rain, cold, or even the glow of city lights. This natural light show has inspired more than tourists. It has sparked technological innovation. Engineers and computer scientists are studying the swarm-like synchronization of firefly flashes to design more efficient traffic control systems and resilient wireless sensor networks, biomimicry at its glowiest. In short, thousands of tiny light sources, each independent yet synchronized, deliver one of Earth's most magical performances, accepted not as rehearsal or choreography, but as instinctive brilliance woven over millions of years. Do birds steal beetle weapons? The Bombardier beetle is nature's chemical weapon. When threatened, it fires a boiling, foul-smelling spray, hotter than 200 degrees Fahrenheit, straight from its abdomen. The blast is created by mixing chemicals in a tiny reinforced chamber, pulsing up to 70 bursts a second to prevent overheating. Some birds, like hoopoes, have learned to provoke these beetles just to get the spray. They wipe the chemicals over their feathers, killing parasites and making themselves unappealing to predators. The smell alone, like burning plastic, keeps away spiders and frogs. Engineers have copied the beetle's design to improve fuel injectors and fire suppression systems. This defense has been around for over 100 million years, earning the beetle the title of the insect world's artillery. How can fish walk on land? Mudskippers are fish that spend most of their time out of water, shuffling across mudflats with strong, arm-like fins. In steamy African and Asian swamps, they roll in wet mud to keep their skin moist. When it's mating season, males leap up to 2 feet into the air and wave colorful fins to attract females. Their eyes can rotate independently, giving them full panoramic vision to spot predators. They dig burrows with air pockets, creating safe rooms from hungry birds. Mudskippers will even wrestle for territory, locking jaws like tiny muddy sumo wrestlers. They can breathe through their skin and mouth lining, surviving up to 3 full days on land as long as they stay damp. Fishermen in India have a nickname for them: frogs of the sea. Why do stoats dance to kill? Stoats, also called ermine or Mustela erminia, are compact and agile predators found across Eurasia and northern North America. They use a jaw-dropping hunting move that could belong in a thriller, a rapid, high-energy dance of leaps, spins, and zigzags designed to disorient. This is not a random display. High-speed footage captured in Scotland reveals that these frenetic performances last anywhere from 15 to 30 seconds before they strike, holding their rabbit prey frozen in confusion. Scientists remain divided on what drives this behavior. Some believe it is a highly evolved hunting tactic. The stoat's erratic maneuvers confuse prey long enough to make them vulnerable. Others point to the brain parasite Toxoplasma gondii, which is known to alter animal behavior. It is most studied in rodents, where it dulls fear of predators like cats by epigenetically rewiring the brain. Some researchers suggest similar manipulation could affect stoats, increasing their erratic displays and risk-taking. Culturally, this eerie routine has inspired myth. Native American storytellers describe stoats as trickster spirits, master illusionists of the wild. Their unpredictable dance becomes a cautionary tale, reminding us how nature's most bizarre behaviors often blend survival instincts with deeper symbolic meaning. How do dung beetles navigate? Using the Milky Way. Dung beetles perform one of nature's quietest yet most extraordinary feats, rolling perfect spheres of dung in straight, unwavering lines, guided not by landmarks, but by the night sky. On moonless evenings, they rely solely on the faint, banded glow of the Milky Way to steer their course. Researchers crafted ingenious experiments to prove it. In high-walled arenas set outdoors, beetles with blocked sky views wandered in circles. But those allowed to see the starry heavens, especially the galaxy's pale stripe, moved in dead-straight paths. Planetarium trials sealed the case. Whether bathed in all the stars or only the Milky Way glow, their celestial guided precision never wavered. This behavior stands out even among insects. While many species use the sun, moon, or polarized light for navigation, dung beetles are the first known to steer using a galactic map, a milestone confirmed in the journal Current Biology. Scientists like Marie Dack and Marcus Byrne, who earned an Ig Nobel Prize for this discovery, study how these tiny creatures unravel complex navigational tasks with miniature brains. Modern engineers now draw inspiration from these beetles. A team at the University of South Australia is developing AI vision sensors that detect Milky Way orientations even in low light, offering a robust navigation tool for drones, robots, and satellites. Through this remarkable fusion of celestial artistry and evolutionary innovation, humble dung beetles remind us, even the smallest animals carry within them the secrets of the stars. Why do Adelie penguins steal pebbles for love? In the icy winds of Antarctica, male Adelie penguins gather pebbles to build raised nests that keep eggs dry. The bigger and better the nest, the more attractive the male. But there's a twist. Some males steal from their neighbors, others trade pebbles for mating opportunities. Females sometimes fake interest, snag a pebble, and walk away, a sneaky move scientists call sexual deception. One long-term study found that males with the most pebbles had up to triple the mating success. As climate change makes pebbles harder to find, some penguins travel more than a mile to gather them, dodging attacks from skuas. In this chilly real estate game, it's survival of the craftiest, and the stakes couldn't be higher.